Well, hello once again, and thank you for joining the Waters and Stanton video channel. My name's Peter Waters and my call sign is Golf 3 Oscar Juliet Victor. I propose to start a new series of videos. Now these videos will just be interspersed with the other ones, but basically a series about historic antennas. You know, over the many years of ham radio, lots of antennas have come and gone. Some of them have stayed the distance, like the G5RV. Others perhaps have been forgotten about. So what I'm going to do is to highlight a particular antenna occasionally and just talk about the history of it, how it worked or whether it didn't work, and whether it's worth looking at today. And I hope that you'll join me on these videos and see whether something that may interest you to try out and experiment with. Now the antenna I'm going to feature in this video is designed by DL7AB back I think around about 1960. Now it's an end-fed antenna, and end-fed antennas in recent times have become very popular because they're easy to erect and they work extremely well. Well, this antenna designed by DL7AB is based around the end-fed ZEP antenna. Now the end-fed ZEP antenna was basically a length of wire fed at one end with open wire feeder, balanced line. And in this particular antenna it's rather interesting because it shows that the insertion of a small coil at the feed point or near the feed point of the antenna, which we now use quite a lot in end-fed antennas, was actually in use many years ago. And I think DL7AB had realised that as you operate an antenna on harmonics, this particular antenna is designed for 80 through to 10 metres, and as you move up through the harmonics, the actual resonant point of the antenna tends to rise a bit. And so there's a need to actually have a sort of a correction coil or inductance added near the feed line. Now I'll put up on the screen the antenna. You'll see it's basically it's an end-fed half wave on 80 metres, so it's 40 metres long, and it's fed in this case with open wire feeder, but of course you could feed it with 450 ladder line, it wouldn't make any difference. But it's interesting to see that he's inserted a coil. Now I'll put on the screen here the coil dimensions and position that he recommended for this particular antenna. And as I say, he claims it covers 80 through to 10 metres. Now on 80 metres it's obviously a high impedance, and of course on all the harmonics it's also a high impedance. So the feed point is a high impedance as we're used to today with the traditional 49:1 UNUN. But he uses balanced feeder. Now it's important to remember that in those days we didn't have 49:1 UNUNs. I don't think ferrite material was used in antennas in those days, and it was very common to have an external antenna matching unit. And the antenna matching units in those days, many of them were designed for balanced line, because balanced line was the easy way to feed an antenna, and it so happens that it's also the most efficient way of transmitting RF to an antenna, because the loss on balanced line is extremely low, much lower than on coax cable. Now in this particular design he doesn't actually state the length of the open wire feeder or balanced line, and I don't think in those days it was particularly important, because the balanced matching units, balanced antenna matching units, were capable to cope with a wide range of impedances or reactances presented to them. So that wasn't really a problem. So I think that as regards this antenna, you can feed it with whatever length of balanced line is convenient to you. And it should operate on the harmonics from 80 metres through to 10 metres. In other words, it should operate quite happily on 80, 40, 20, 15 and 10. What happens to the walk bands? Well, in fact, they take care of themselves to some extent. They will present a medium impedance at the feed point, and the balanced line will quite happily feed that. So As we found in the past, an end-fed antenna is a very useful antenna. It's very simple to put up. And because we're using balanced line on this antenna, it should be quite happy on whatever frequency you like to operate on, provided that you've got a balanced matching unit. Now, there's not many balanced matching units around now. KW Electronics made quite a nice one, and there was one or two American designs, but you'll be hard pressed to find one now. And if you do find an old KW Z match, then buy it, because it's pretty unique. However, you can get over that, because a lot of the modern antenna matching units, and particularly those that came out of the MFJ factory, and of course there's thousands of those around, they will have balanced line facilities on the back, and you can connect your 450 ohm ladder line to it. But if you haven't got one of those antenna matching units, but you've got one that is designed for coax, then generally speaking, all you need to do is to add a 4-to-1 balun at the point where the balanced line would go into the ATU. In other words, you put a 4-to-1 balun between the antenna matching unit and the ladder line that you're feeding, and you'll probably find that you'll be able to match it okay. So it's a very simple antenna. It's interesting that even as long ago as basically 1960, it was realised that that small coil would add particularly to the performance or the matching on the higher bands. So there we are. It's an interesting antenna. Give it a whirl, see how you get on, and you may be pleasantly surprised. And all you need is some wire and a bit of balanced line, and you may be in business. There we are. So thank you for watching this video. Thank you for your support on this channel, much appreciated. Don't forget to press the subscribe button, and in the meantime, enjoy your ham radio. You take care. Look forward to seeing you in the next video. Bye for now.